We are built to believe that artificial intelligence reads our words. When you type a prompt, it looks like a conversation. But behind the screen, the machine instantly shreds your language. It does not read your words. It translates them into thousands of decimals, turning your thoughts into GPS coordinates. To an AI, meaning is not a feeling, a definition, or a concept. Meaning is a location in a silent, multidimensional desert. This is the story of how machines mapped the human mind, and why that map is starting to warp. In 2013, a team of researchers at Google, led by Tomas Mikolov, proved something remarkable. They realized you could map the relationships between words using basic geometry. If you take the numerical address of the word king, subtract the address of the word man, and add the address of the word woman, the closest address in the entire system is queen. This was not a fluke. It revealed that human language has a hidden, highly consistent structure. By analyzing billions of sentences, computers could assign every word a coordinates file. This file is called an embedding. It represents a single point in a coordinate system. On this map, words that share a meaning are clustered close together, like houses in a neighborhood. Hot and cold are close because they describe temperature. Coffee and morning sit on the same block. But to build this map, the machine had to escape our three-dimensional world. Imagine trying to organize every object in the universe on a physical shelf. If you only have one dimension, a straight line, you can only sort things by one trait, like size. A mouse is next to a teacup. If you add a second dimension, a flat grid, you can sort them by size and weight. Add a third dimension, height, and you can sort by size, weight, and color. But human thoughts are far more complex than three traits. To capture the full meaning of a word like democracy or nostalgia, a three-dimensional space is uselessly small. So, modern AI models do not use 3 dimensions. They use 1500 or even more. We cannot visualize a 1500-dimensional space. Our brains are hardwired for 3. But mathematically, the rules of geometry remain exactly the same. In this hyperdimensional warehouse, the machine has enough room to map every subtle shade of meaning, every historical context, and every emotional undertone of human language. When you step into 1500 dimensions, the laws of physics and common sense break down completely. Mathematicians call this the curse of dimensionality. In our three-dimensional world, if you drop 1,000 marbles into a box, most of them will clump together in the middle. But in a high-dimensional box, something bizarre happens. The volume of a hyperdimensional cube is concentrated almost entirely in its outer corners, not its center. If you drop 1,000,000 coordinates into a hyperdimensional space, they do not clump in the middle. They migrate to the extreme edges. Even stranger, almost any 2 random coordinates you pick in this space will be perpendicular to each other. They sit at exact 90-degree angles. In high dimensions, everything is incredibly far apart, and everything is isolated. To navigate this vast, empty expanse, AI cannot use normal distance. It has to measure the angles between vectors instead. If 2 vectors point in the same direction, they are conceptually similar, even if they are miles apart in the dark. Early AI maps were static. A word had one address, and that was it. But human language is a moving target. Consider the word bank. Is it a place where you keep your money, or the muddy edge of a river? If you use the word play, do you mean a Shakespearean tragedy, or a child with a toy? Modern AI architectures, like the Transformer, solve this. They do not use fixed maps. When you write a sentence, the model uses an attention mechanism to look at every word simultaneously. It calculates how each word influences the others. If the sentence mentions water, current, and fishing, the attention mechanism dynamically pulls the coordinate for bank away from finance and slides it thousands of miles across the hyperdimensional space toward nature. The map is not a dusty atlas. It is a shifting ocean of fluid coordinates, constantly recalculating itself with every word you type. This geometric mapping is not just academic theory. It is the core infrastructure of the modern tech economy. Every time you ask a custom AI assistant a question about a massive corporate document or ask a search engine for a complex answer, you are using a vector database. Standard databases search for exact words. If you search for canine, they might miss a document that only says dog. But a vector database does not care about spelling. It converts your query into a coordinate and looks at its immediate neighbors. This process is called vector search, and it happens in milliseconds across billions of data points. It allows AI models to have a form of long-term memory. Instead of trying to remember everything in its active brain, the AI converts its knowledge into coordinates, stores them in a vector database, and retrieves them whenever your question lands in the same neighborhood. But these maps are not perfect mirrors of objective reality. Because they are trained on human writing, they inherit all of our cultural baggage, stereotypes, and systemic biases. If historical text repeatedly links specific professions to specific genders or ethnicities, the AI maps those concepts closer together in its coordinate system. These biases are not easily erased because they are baked into the fundamental geometry of the space. Even worse, these spaces can be weaponized. Security researchers have discovered that malicious actors can perform vector injection attacks. By subtly altering the wording of a document, they can shift its coordinate address just enough to bypass safety filters or trick an AI into executing malicious instructions, all without changing the visible meaning to a human reader. The geometry that gives the AI its power is also its greatest vulnerability. We are now entering a new era of representation. AI researchers are no longer mapping just words. They are mapping images, sounds, video, and even genetic sequences into the exact same coordinate space. When you use an image generator, the AI takes your text coordinates and finds the corresponding visual coordinates in the same neighborhood. It is a universal translator, not between languages, but between senses. We used to think that human thought was something mystical, impossible to capture with math. But embeddings prove that our concepts, our culture, and our collective knowledge can be mapped, measured, and navigated. The machine does not understand the soul of our words, but it has built a map of our minds so precise that it can find its way home in the dark.